Welcome to our Generative AI demo series, where we are showcasing the security, delivery, and optimizations of modern generative AI applications with F5. In this next installment of our Agentic RAG demo video series, we are diving into the security aspect of F5 security controls. These demonstrations will highlight the various security measures implemented and enforced in our AI reference architectures for these Agentic RAGs. For those who have missed our previous video, which introduced the overall reference architecture, I encourage you to take a look. It provides valuable context for this demo. Before I get into the demo and show you how our environment is protected, let me give you a brief overview of the 6 key security controls that are the heart of this architecture. We have web applications and API protections deployed and in positions to constantly detect, monitor, and prevent any malicious intent targeted at both our front-end applications and our generative AI chatbot. API are essential for AI, as is enabling communications between AI-related components like language models, accessing data, and integrating systems. It is a core component of an AI's ecosystem. F5 platforms secure API with advanced monitoring, discovering both known and unknown API through live traffic and code analysis. It also assesses API against industry compliance framework, ensuring security standards. By enforcing API compliance, stakeholders such as CISO and CIO have visibility into maintaining API security, where non-compliance API being blocked for integrity and reliability. In addition to our advanced API security capabilities, I also have web application scanning tools integrated into the whole ecosystem. This provides a comprehensive 360-degree security posture view for both outside and inside. By combining WAP, advanced API security, and web application scanning capabilities, we are able to provide an unparalleled level of protections against cyber threat. Our integrated security posture view gives us complete visibility into the security risks facing our web and AI applications, allowing us to respond quickly and effectively to any potential threat. As we discussed previously, all sites are connected via our F5 encrypted mesh fabric, which provides an additional layer of protections by ensuring confidentiality and communications integrity between all components. We implemented a zero trust application access approach where AI components can't communicate without explicit permission, using default deny rules to restrict traffic. This model enhances security by controlling and monitoring communications between components, preventing unauthorized access, and reduce the attack surface, all while the F5 mesh fabric to connect sites and components. Visibility and observability are crucial for security, as you can't secure or protect without being able to see what's happening. The F5 platform provides a single pane of glass that offers comprehensive visibility and observability across all communicating components, allowing us to monitor traffic flow, detect potential threats, and respond and react quickly to security incidents. All these 6 key security controls work together to provide a robust security posture for our generative AI application. Now, let's take a closer look on how those security controls are implemented in our environment. We have deployed web application and API protections on the F5 global network, ensuring that all traffic passing through our infrastructure is constantly monitored for good and bad traffic. By deploying WAP on each site, we are able to verify the authenticity of incoming and outgoing traffic, ensuring that no malicious activity can go undetected. It is a trust no one. We always verify, which means we never take anything at face value. As mentioned, API are essential for AI. For API-based communication in our generative AI applications, we have enabled API protections and discovery from traffic. Additionally, we integrated code analysis tool to discover known, unknown, or potentially dangerous API from code repository and correlating them back to build a centralized 360-degree view of API. This integrated approach detects and prevents API-based attacks, identifies authenticated and unauthenticated API, and correlate activity with other security threats. By leveraging this comprehensive discover, governance, and protect strategy with API, we maintain the trust and confidence of our users and stakeholders. As encrypted mesh fabrics safeguard communication between all AI components, ensuring both confidentiality and integrity are maintained. Web app scanning is deployed to dynamically and continuously monitor both external and internal attack surface, identifying exposure or exposed web applications and API. Every entry point in our environment is constantly monitored with metrics and logs being collected and visualized on the F5 console. This provides real-time visibility into network's activity, enabling us to quickly identify potential security threats or issues. Now, take a closer look through the F5 console on how these 6 key security control in action. This is F5 Distributed Cloud Console, and I have 5 sites registered onto F5 console. This is F5 Encrypted Mesh Fabric. As shown, I have 4 healthy sites connected to each other forming a mesh fabric. Communication between all sites are encrypted to ensure confidentiality and integrity. AI components that sit behind all these sites can't communicate with each other unless explicit permit rules created. Here is my AI application access control. I have various load balancers created with associated security controls. I have some API gateway used in this demo like User Management System and Morningstar. I have private LLM web UI as well as AI Factory API endpoint setup. I also have LangChain for on-prem and cloud load balancers created. LLM model resiliency load balancers. I have LLM gateway set up as part of the demo environment. Open source S3 compatible MinIO storage and API being set up for RAG data preparations. NVIDIA Inference Microservices or NIM embedding model being deployed, and finally, I have vector database access been provisioned and replicated across the 2 data center. Here is the security posture view of the overall application. Dashboard provides immensely amount of actionable insight onto the posture of attacks and health of your application. Malicious User tab provides global insight into the activities against your applications. It leverages machine learning technology to track user activities and associate it with risk profile for a period of activities. Threat campaigns provide sources from varieties of threat intelligence based on real-world campaigns to attack and take over resources. F5 Threat Research team is constantly monitoring malicious activity around the globe and creating signatures specific to this exploit. Let's move on to see how our API security being addressed. Here is our backend API gateway currently protected by F5 API security. As mentioned, API is crucial for AI. Visibility of API inventory and its associated risks are crucial. They are all the API being discovered by F5 through live traffic as well as source code analysis. F5 platform able to mark those API against certain API compliance framework. We are able to identify if API being authenticated or unauthenticated as well as authentications method used. This shows that those API being discovered from the code analysis. Those API not discovered yet from the traffic. This potentially means that those API creates in the source code but not being used. We can also display the associated API information into a pictorial send key graph for easy analysis. Similarly, this capability is also being activated for the front-end applications. These are examples of an API that discovered from traffic as well as code analysis. Let's experience one of the security controls implemented in actions. Our generative AI chatbot is being protected by user authentications flow. This authentication flow is protected by AI-powered bot defense, which currently configured to flag or monitor only. Currently, dashboard shown 10 human logins activities. Let's log into Acadia Financial's login page to access the Gen AI chatbot. Now, the dashboard shown 11 human interactions to the system. In order to attack the Gen AI chatbot, attacker potentially may run credential stuffing or brute forcing to pass the authentications flow to get to the chatbot. I'm going to simulate a credential stuffing attack on the login page. As you can see, attack tools automatically launch a browser and start to log into the web page with combinations of username and password. Currently, these activities wasn't blocked and bot defense dashboard shown immensely increase of bot activities. Let's enable the blocking mode. From what you probably can see, the login page being blocked as shown quickly on the attacker browser. This demonstrated that bot defense in actions blocking all those malicious bot activity. At the same time, we can validate to ensure legitimate users are not blocked while malicious intent being blocked. Let's conclude this credential stuffing simulation. Let's move on to our next security controls, web app scanning. F5 Distributed Cloud Web App Scanning is an offering that lets you discover, expose assets, and run automated penetration testing of your web applications and API. This is the scanning result from outside the organizations. Acadia front-end apps as well as LangChain Gen and AI apps being pen tested for security vulnerabilities. It provides a simulated cyber attacks against those systems to check for exploitable vulnerabilities. Weekly schedule scan being configured to pen test periodically to ensure identifications of any potential applications or API vulnerabilities. The scan service document every step of the penetration test with videos, screenshots, and test cases. This allows you to examine all pages and page elements that have been crawled and tested. These documentations can be used to verify the results of the penetration test and to identify any false positive. In the event if the vulnerability is found and the affected application hosted on F5 distributed cloud, Web App Scan able to fix the vulnerabilities by applying a virtual patch onto the offered HTTP load balancer. As shown, a virtual patch is applied onto the particular load balancer. This is another view where the web app scanning deployed inside organization premises. Internal web app scan can be used to pen test any internal application that not reachable from internet. I have Olama API Gateway, User Management API Gateway, as well as vector databases domains being pen tested internally. Similar with public-facing applications, there are few identified issues that need to be fixed. Trust is essential in security, creating a dependable foundations between organizations and their protective technologies. A trusted vendor consistently proves its ability to safeguard data, manage risk, and counter threats, allowing organizations to confidently dependence on these solutions. F5 is a trusted leader in security, with a track record of delivering robust solutions for securing applications and networks. Recognized by many independent evaluations as a leader in web applications and API security, from IDC, SC Award, TrustRadius, EMA, and many more. F5 exemplified excellence and innovations. This endorsement affirms F5 expertise, reassuring organizations that their digital assets are protected by a capable, reputable partners that keep pace with evolving security threats. I hope you find this demo informative and helpful in understanding how F5 addresses enterprise concern on protecting and securing their web applications, API, and AI applications. Feel free to reach out if you need any further deep dive session. Thank you.